I'm the co-leader.
Yes, I'm here. Good morning, everyone, and welcome to the third day of our IGLUNA virtual field campaign. Today, we start with a project show from the team ZHAW from the Zurich University of Applied Sciences in Switzerland. They will tell you about their idea of a plant vending machine. Please don't forget to submit your questions and comments in our YouTube chat. The students will address them after the presentation. Thank you for joining and welcome, Team ZHAW.
Hello and good morning to the ZHAW project. My name is Philip Osterwald, and we are streaming right now live from Alpnach, here from Luzern. By my side is...
I'm the co-leader from Team ZHAW, and I'm responsible for the lights and plant publications.
We want to present you our developed system, like the ZHAW system. ZHAW is Smart Waste-Based Agriculture Growing System. And what is our why? And why we built this system? You will see it right now. Welcome back to the ZHAW project show. Let me introduce you a little bit more about our system. So, first of all, go right now on strawpoll.me and type in the number 20 56 66 92 and decide which of these ZHAW topics we will explain a little bit more in detail. So right now, go to strawpoll.me 20 56 66 92 and choose one of these topics. Let me explain a little bit more about the ZHAW system. So first of all, we have a closed plant cultivating system. It has integrated a circular hydroponics system. We have integrated fully adjustable lights for a healthy plant growth. Also, a climate controlled environment. So also there are some sensor meshes with microcontrollers and a smart control. All of the core functions will be remotely controllable. During the last 9 months, we had a lot of different kinds of steps. So here is the ZHAW evolution. And we came up with just one last system. Let me introduce you, just as a IGLUNA premiere, the ZHAW X-Think prototype ZHAW system. So where we are right now streaming live from Arovis in Alpnach. If we look out the window, we see Mount Pilatus. The setups for the system is a diameter of 1.2 wide, 1 depth, and 2.10 high. The full system have a weight of 400 kilograms. The energy max is 3 kilowatt. We have a water tank inside. The volume is 45 liters. We have a heat release of 500 watts. Let me introduce you to the crew. So myself is Philip Osterwalder. By my side,
Ray Moberholzer, I'm co-leader.
We have Edmund Peritats for the marketing and communication, the Stefan Schmutz on the streaming right now, and he's responsible for the plants. We have Sarah Blinkensdorfer, who is for communication and the campaign management. And we have Samuel Beer, control and network, Michael Blinkensdorfer for project management and system engineering, Lukas Bernhard, system design, and Mike Markthaler for front-end developer. This is our board from the Zurich University of Applied Science. We have different kind of process and lectures for different intercultural of the different topics that we use and integrate of the technologies inside the system. So go a little bit more in detail for the system subsystems. Please, let's see, start with botanic. Let's see what's inside. We have a current setup with 3 levels. On each level, there can be different kind of flow channels, amount of flow channels. On the highest level, there will be 4 flow channels. On the middle, 3, and on the bottom, also 3. We have on each level 2 LED modules. We can put inside, we have 2 different sizes, 6 or 10 plants per flow channel. So we have at least on each system or each on level, plants per level, like 40, 30, and 80 plants. That's altogether an amount of 88 different kind of plants. How does it work with the plants? So first of all, we take the seeds, we put them in the substrate. We are doing some tests. We are doing some tests like substrates in rock wool and in hydrocorals, and put these inside the pots and just easy to use inside the hydroponic system. So how does it look like with the hydroponic system? There will be different kind of flow channels. So there are different kind of schematics on the top. So we can choose if there are big plants for like 6 plants inside, like salad, they grow a little bit more with space. Or we have a 13 flow channel, there can put some inside smaller plants. Let's go to the hydroponic. How does the setup works? So on the 3 different kind of levels, there are all the hydroponic channels, like the flow channels, they are connected in a cascade flow. We pump it from the bottom to the top level, and then it flows like through gravity down to the water tank again.
Okay, so going to the lights. I'm responsible for the lights, and I developed smart grow lights from Aurora, and they are quite innovative. There's a quite innovative design, but I will go into further details if you voted on SproPolMe for the Aurora lights. Here you can see how the light a bit works. So the light itself is fully dimmable. It can perform a full day sun course from the morning rising sun to the midday with lots of UV inside and to the golden sunset. It can perform different climate zones, various high profiles and weather simulations, all depending where the plant naturally lives in. So for example, here I have a Vanilla planifolia. It's a vanilla plant, if you can see it here. And this plant is naturally growing in a tropical forest, so it needs less direct sunlight, even not direct sunlight, but more of the bluish content. And here is a tobacco plant. This one needs a lot of direct sunlight, and the more UV we put inside, the more nicotina content is putting into the leaves. So with my lamp, the lamp is capable of having a perfect light for every plant. So here you can see different lamp profiles. So on the bottom right, I have vapor lamp, sodium pressure lamps, and normal tube lamps. They have all of spectra. But I have a fully changeable spectra. So whatever I want, I can do and perform. And everything is highly efficient. So the spectrum mix from the Sunday course, the spectrum mix is looked up from a full Dunsay course. So I performed here on the 3D plot a full sunlight course, And as you can see here, the bluish content rises way more to the midday than a red content, for example. So that's all dependent on how much air mass it has to go through the light.
Yeah. So let's go to a little bit more in details to the structure. We have aluminum profiles, standard aluminum profiles on the corners, and have the flow channels hang up with some metal rings. So on the cover, we use plexiglass, and on the bottom, there will be a textile. Why? The milky plexiglass will be cover the plants from reflecting light from outside and keeps all the artificial lights from inside, from aurora, and keeps it there reflected inside. Textile is a nice detail to make it more comfortable and look it more cozy, like you have it in your living room. It makes it more like a cupboard or like a vitrine, like an aquarium or a plantarium. We have made the setup and the construction like modularity. So there's possibility of 4 levels and even put inside more levels, more flow channels on each level. There could be at least more plants inside and different kind of crops with the special wavelength and the special spectrum for each plant. The whole system can be controlled by a dashboard and showed by a dashboard. So here you can see the first draft of our dashboard, which shows the temperature, for example, the CO2 level, the humidity, or on the bottom, the nutrition data, which will be from the fertilizer inside. Also, there will be a status of the water tank and the volume. Also, the light mix from the different kind of levels in the system. On this point, we want to say a big thank you to all our partners who make that possible to develop and construct this system here at our office in Alpnach. Also, a big thanks to our sponsors, which provide us materials or manpower to get this system real life. Why we do this system and why we work together for the last 9 months so hard for that? Because we want to grow food everywhere and beyond. It's just that easy. And we want to do that everybody can be just a farmer. If it's be at home or even in the industrial kitchen or even beyond on Moon or further on to Mars. This was our core presentation right now till this point. So let's see which topic do the viewers choose to go a little bit more in detail. And I think, what do you think? You're smiling?
Right. Yeah, everyone, thank you very much. It's a pleasure for me to explain it a little bit more. So,
Aurora wins with 35%.
Michael, kannst du mir gerade das nachgeben, bitte?
So let's go a little bit more in detail to Aurora lights.
Dann muss man eigentlich geben 3 Stifte geben. Geben 3 Stifte geben. All right, so that's my lamp here. And the very speciality from this lamp is, first of all, it's very efficient. It uses the latest technology of LED components. It uses, first of all, LM301Bs. It's a PVM module, PVM dimming. So, and the system here, it's powered with a little microcontroller. The microcontroller mixes the daylight in order to get perfect sunlight. So the performance here is we have an efficiency up to 95%. The biggest loss we have is on this huge PSU here. So yeah, that's like 4% of our whole loss. We have an illuminance of 78,000 lux, and that's not really proper. For the plant applications, we're using PPF, PAR, but we have also a very good PPFD content. So this lamp is capable of performing a spectra from UVC to infrared 900 nanometers. So there is a lot of things to be discovered for example, UVC. There is thinking that we could, with short bursts of UVC light, we could treat fungi on the leaf surface. For example, the male ZHAW, I don't know how it's called in English, and not destroy the plant itself. So that we need less a fungicide and treat it like, yeah, just with light. So with UVA, for example, you can get slower growth and thicker trunks of the plant. With a lot of bluish content and red content, you can accelerate the photosynthetic rate. And with near and infrared, you can also make profit of the Emerson effect. The Emerson effect is stating that with infrared and near infrared, the plant can even perform more photosynthetic rate than it usually does. So that's all because of the morning sunrise and the evening sunset. If in between the sun is too hot, the temperature is too hot, the plant cannot get the plant cannot perform photosynthetic cannot perform photosynthetic rates. So with this infrared and near infrared, the plant does it more in the morning and in the afternoon, so that it can even grow in arid and hotter climates. So yeah, go further. And here on the left side, you can see a Gravita Pro. And Gravita Pro is hanging up there. It's not on right now, but in the normal agricultural applications nowadays, still in Switzerland, we are using still the Gravita Pro, the sodium pressure lamps. And we thought it's very efficient, but it isn't, in fact. And you can see here why. Most of the sunlight, most of the light it emits is on the green content and on the orange. But as we know, the blue and the red content is the content the plant uses the most. So with this LED here, we can really interact and put in the real spectra every plant needs and every special plant needs. Yeah.
Thank you very much.
You're welcome.
Very nice, very cool lamp. So the next step will be a live cam, so first of all, have you back. And now we will change to the live stream to see our current status of the system. So we will change that. Go to our cam. And now we switch to the live stream. And
okay. All right. So that's me on the screen here. Okay, now Philip is going to the system. The system is still on the construction, as you can see here. It will be finished on Monday, I guess. So we are working really hard. So on the very right side, you can see Sarah. She is already putting the HAC sensors inside. We have HAC sensor for measuring the nutrient content, the pH level, EC level, and everything it really needs. So all the sensor data from there goes up to the cloud and into a screen on the dashboard, as you can see in the middle here. So on the screen here, yeah, right now is Michael installing it. I can see it. So everything is displayed afterwards on the screen. And on the screen, there is another one. There is a button you can then click, and you can say, okay, let's grow something. And if you want to, I can see Edme is putting basil inside. So you can put a button and say, okay, let's go basil here. And the lamp will have the perfect light spectra for the basil. Oh, Edme is tasting it. Ooh, it must smell delicious, because with more of the UV content, the basil smells way better. Trust me. So yeah, they're all working hard. Even Samuel is working very hard. They're discussing it. And I think, yeah, it looks like that he will be nearly finished soon. So do you want to have also a look to our streamer? So over here, you can see our streaming specialist, Stefan Schmutz. He's very busy right now, so we shouldn't distract him too much. but he's doing a great job so far, and we are very proud of all our members. They are really giving their best, trying their best to have everything finished on Monday, and even he is trying the best to give us on the brightest lights, so that we are all getting to be shooting stars. Yeah. So come on, take a seat, Philip.
Thank you very much.
Thank you very much for showing them our system.
So let's change the camera again. Welcome back. Thank you very much. So that was our presentation for the swag system. You meet the crew, mostly of all of the team members. You saw our current status. How does it work like? We will be finished planning next week to try this prototype and do the first tests with the plants inside and the hydroponics and all the electrical stuff. And
follow us on Twitch, on Instagram, on YouTube, and have a look on how our system grows. So it's quite amazing, and trust me.
We will see us at the Q&A, and now you see our live stream on Twitch. Have fun. Welcome back. Thank you very much. So that was our presentation for the swag system. You meet the crew of the team members. You saw our current status. How does it work like? We will be finished planning next week to try this prototype and do the first test.
Thank you very much, Team Swag, for your interesting presentation and for the possibility to have a look behind the scenes with your live stream. And I see the audience is really interested to know more about your project, and we have a lot of questions in our YouTube chat. So let's start with the questions. How do you think the public would react to seeing your system? Do you think the world is ready to welcome this very innovative system and implement it in our daily lives?
This is a very nice question. It's right now at this current status of the system very hard to explain, because the size of the system is not very commercial. There is a big problem about scaling. So, but it could be possible if it works more efficient, and if we try, or if we can get to grow even more plants, exotic plants, very kind of crops inside, healthy, tasty plants inside the system, there is a chance that we can sell the system. It depends right now on the price. Otherwise, right now it's too expensive at all. It makes no sense to sell it. And it has to be consumer friendly. For the design, we thought to make it like look more to do it or build it inside a living room, like you put it next to the TV or right into the kitchen where your fridge is, to build it right inside a habitat, even on moon. And it looks nice and it works nice. And I hope the viewers and the public will love the design as well.
And I mean, the lamps are ready. So there is just a system to put outside of the lamps. So yeah.
Indeed, thank you very much. I see the public is really interested to buy your system. I have a second related question. Is your technology expensive? Can you give a price range?
It's pretty hard to say. So we have some sponsors, and we had a crowdfunding campaign in March, and we raised 15,000 Swiss francs, and they're all gone. For all the structure and the design and the different kind of materials that we use. Right now, the prototype, like it is here, is around 100K. But we think we can mention the price for that.
Yeah, I mean, like there is a lot of things we had to put inside, and we did wrong, and so I guess the price range right now would be like around 35K. Yeah.
Too much.
Thank you. Thank you. Somebody is asking, how is your project better than the already existing technologies? Can you tell us about it?
So we use the NFT system for the hydroponic. It's just another innovation that there are already a proof of concept that it works with grow plants inside. The new technology is
The lights,
of course.
And yeah, because when you have lights that make the plants fresher and healthier and even smell better, as you could see, all right. So that's quite an innovation, I guess.
And we want to provide a closed system which control the whole growing process of the plants. So we designed it as simple as possible, to control it as simple as possible, and to replace some parts. If there are anything broken, you can do it by yourself at least. And we have it's semi-automatic, we have 2 steps that you have to do by yourself. So step 1 will be planting by yourself inside what you want to grow and eat at least. And the second manual step will be you will put out the plants and don't have to wash it, just eat it directly.
But it's fun.
Thank you. Speaking of on the plants, I think I have a couple of questions related to that. Do you sterilize seeds to reduce contamination before sowing?
No, question.
Can you repeat it? Sorry for that.
Sure. Do you sterilize seeds to reduce contamination before sowing?
Können Sie sterilisieren?
Sec?
Yeah. Right now, for the Earth application, we are not sterilizing it, but for the moon missions, of course, we have to do something. Otherwise, we have like huge problems. Yeah.
I see. And I have a related question. Are you using any methods for fighting against parasites, harmful insects, if they arise?
Right now, we're not using it because we are not needing it. But on the lands, there are UVC components inside. So with further tests, we're pretty sure that we can fight against insects and fungi and every other threats. But yeah, there is, for every plant applications on the moon, there are some things there are some things you have to have in order to have fresh and healthy food and not having it killed right before it's harvested.
And do you have to use some pesticides, or are your vegetables 100% organic?
Right now?
We don't use any pesticide. We just test, or will test the system next week with conventional fertilizer. There will be no sprays, no herbicides, no pesticides, nothing else. There will be fully biological. So you can grow it and put it outside the system and eat it directly.
Thank you very much for the answer. And could you remind us about which varieties of plants are you cultivating or you're planning to cultivate inside your prototype?
Thanks for that question. Variety of plants.
So yeah, we have quite a lot of varieties, of course. We plan to have rice on the lowest part of the channels. We have like dragon fruits as a part of the very special plants. And then we have salad, like microgreens. We're using fennel. We're using, you can see here the vanilla planifolia, which grows like as a vine through the system and on the whole system here. We're planning to grow tobacco, a smaller variety of tobacco. And like here for the other group, there is a group which wants to have coffee on the moon. So we decided to grow some coffee Arabica on the moon. And with a nice collaboration with them, we can get the best coffee you ever tasted.
Space coffee.
Thank you. This is very nice of you. It's great to see collaboration between IGLUNA teams. So, and a great variety of plants indeed. So I had one question from the audience, but I guess we can say that you already answered it. The question was, what if the astronauts get tired of eating the same plants for a long time? But I suppose with such a great variety of plants that you just mentioned, that should not be a problem for the astronauts.
Exactly.
So let's have a look at other questions. What should be, in your opinion, the most optimized plant distribution for your system and why?
Sorry?
What
Can you
should be,
repeat it
in
again?
your opinion, the most optimized plant distribution for your system and why?
Plant distribution.
Yeah.
I don't understand the question. I'm sorry.
Can you rephrase it?
Well, this is not my question, so I cannot rephrase
What
it,
does
but
it
I
mean?
assume it's probably also about the
Das
variety
optimierteste
of plants, maybe different
Plant
levels
distribution
that you have in your system. How would you decide which plants you grow, I assume?
Ah, okay. I know.
Okay.
Yeah, I try
Right.
to. If that was a question, we try at least, if the prototype is built, to get a full healthy diet, to grow as much like vitamins inside the system with the plants that we grow, to provide a healthy living for the astronauts. So the food that astronauts have right now is not really fresh, not really tasty, and doesn't look very yummy. That's why we go with this like kind of veggie vending machine that you can see the plants growing inside and get like a connectivity between humans and plants. This is a very important part, because if you are an external planet like Moon or Mars, you don't have that connectivity between such animals, humans, or plants. And even on such an environment, extreme environment, you could be, after a couple of months or years, you just start to missing the sound of rain. And this is like the same, the connectivity between humans and plants. And we decided to go ahead with some tests to provide as much nutrition for a healthy body functions as possible with some different kind of crops.
And imagine if you're after a long moonwalk, what is better than have a fresh veggie and fresh meal? There is nothing better, trust me.
Smoothie.
Yeah.
I trust you. So we had a very nice discussion about plants. Now let's talk a little bit about more technical part of the system. Your sensors, could you tell us more about how, what exactly are you measuring with the sensors? What kind of sensors you have?
Okay, so we're measuring the NPK level. We're measuring the pH level, the EC level, so the electrical conductivity. We have also ammonia sensors. We have O2 sensors in the water. And so everything for the water here. And then we have humidity sensors and humidity and CO2 level sensors on each level in the grow chamber. Then we have a sensor, a CO2 sensor and an O2 sensor on the exhaust fan air management. And then we have temperature control systems each level as well.
Very good.
Thank you very much for your explanation. Now talking about the future and one day seeing your system on the moon, how do you plan to adapt it, and how would you achieve gravity flow under the microgravity conditions?
This is a really good question. So first of all, that size is not really big. So we mentioned before, it's like a cupboard or a cupboard for clothes. It's not that big, or like a fridge. And it's easy to handle that, to bring it up on a lunar base or even to Mars. It is right now built for gravity. Of course, for the cascade flow, we need some gravity that the water can flow down. We have some plans to adapt it to a microgravity, like to change from NFT hydroponic to a fogponic system, like it's used already in space. We have some plans, but we didn't build it right now because we have decided to build up first a proof of concept of this prototype and then rebuild it or go ahead and develop it furthermore. At this point, we want to say a big shout out to Think About Design, who work and collaborate with us to get this design like it is right now out of this system. Thank you very much to Think.
Thank you very much. And I have one more related question, I guess. Is there a potential to make the system vacuum compatible to allow for use on the lunar surface?
Yeah, there is, of course, but we should exchange we have right now not glass as a It's a covering system. You just have plexiglass, and that's not strong enough. But with the aluminium construction we have, there is a possibility. There is just a small thing like with the air inlet and outlet, but this is for sure makeable.
Thank you very much. Now that you mentioned air inlet, I have a question from the audience asking, are you filtering air?
Okay. Right now, we are not filtering the air, which goes inside the systems. We are just checking the quality of the air. But you can set it up with a carbon filter. You can set it up with UVC treatments, so that it's really without any fungus and bacteria and stuff. Yeah.
I can add to this that we don't filter air, we filter water. So we can use wastewater at least, or even tap water, and make it like osmosis to get a fully calibration of the system. So we get conductivity of around less than 10. Yeah,
that's right.
Less than 10 to make a calibration and to add the exact amount of fertilizer into the water tank to provide the right nutrition levels for the plants. So we have a osmosis filter from Ubuntu inside the system.
Thank you very much for your answer. And now that we are on this topic, I also have a question from the audience asking, what nutrient solution do you use?
Okay. So right now we're not using a self-made nutrient solution. We have one of our sponsor we're using. It's one of his main thing. He's producing it from Holos. He's doing it on his own. He has a company doing it, but
his own brand.
Yeah, exactly. And we're using it this way because it's cheaper for us. We haven't had to pay for this, but we planned really to have NPK fertilizers to mix it on our own, because we are already capable of measuring every substance inside, every nutrition part of the nutrition level itself. So we are actually right now already capable of, but we have a lot of other things to do. So that's just the next step.
Indeed. And another question from the audience, how do you control algal blooms?
So yeah, we are using conventional fertilizer, not biological fertilizer. So there is less, on the beginning, there is less algal bloom. There is a potential to use UVC treatment in the water, as you already have it in pond systems, to clear the water and to really sterilize it. But as we already explained, we have not used anything of that, but we're really trying to get the light out of the water thing. So we're using black tubes. We are really sealing everything so that it stays away from the light, the water.
Thank you very much for your detailed answers. So now we have learned more about the details of your system, but I see the audience is also really curious about the project itself. So somebody from the audience is asking, where is this work right now? Is it a startup, university project, formal business, or just a research-oriented idea at the moment?
Right now we are just a students project. We are built this up with students and some team members who are workers, not from the University of Applied Science. So we are a team from around 10. And the idea is to develop this system further on. So we see a lot of potential, not only in this system, just in vertical farming around Switzerland. And we want to provide this system to as much people as possible. For that, we have to raise more money, and we have to make a startup out of this. And there was an idea to go, or to plan at least a Kickstarter in winter as a sneak peek.
Thank you very much. And I have one last question. Why should your system be ready exactly on Monday and not already today?
Because it was my promise. I had a small delay with the lights, and but it's fixed right now. So I was really hard working to have a lamp put up on the system, and I am really finished Sunday evening. And then there's just the thing to put all the channels inside again after I finished, and to put all the ceilings down. And then, yeah, I promise you it will be finished on Monday, not another day.
I can add to this. So we had a lot of problems, not only about COVID-19, just with the delivery of some parts. They had some issues. There was partly broken, and false manufacturer with different kind of sizes. We couldn't use that to build it, to put it inside the system. And like Remo mentioned before, we got the last parts yesterday, express, the overnight delivery, to use it in the system. And there are a lot of other issues that we had to get such a different kind of, like the flow channel caps are made out of this multi-jet fusion, is a special kind of 3D printing. And there was also pretty hard to find a company which provides such material, like with this physics property.
Yeah, properties, yeah.
I see. I guess the audience was guessing whether it was done on purpose so that you can have a chance to show the live work, but now we know the truth. So thank you very much. That was our last question from our YouTube chat. Thanks everyone for submitting the questions. That was a very interesting, very detailed discussion about learning more about your SWAG project. With that, I would like to conclude this session. Thank you again, the SWAG team, for this very nice presentation. Thank you everyone for watching us, and hopefully see you again in 1 hour for our next project show. Have a nice day. Goodbye.
Thank you.
Thank you, you
Bye.
too.
Join us.
Big shout out. See ya. Bye-bye.